going to start with the decay, reversion, reduction to ash. Okay, this is the laws of thermodynamics. This is what's going to happen to the universe. Okay, you have to understand this to explain, to understand what I'm going to explain. Okay, now the Big Bang, you have it exploding. Okay, it starts to burn out. Entropy and reversion begin. The heat and energy reduce as matter reverts to ash. Okay, the entropy is the energy, it losing energy. Okay, the reversion is the matter turning back to ash, the carbon. Okay, eventually all sparks or stars burn out, reducing back to ash. Okay, stardust. All right. Okay, once it reduces so far, it's at near ground state. It's near zero, absolute zero, but it can't ground out at absolute zero because there's no ground. Okay, this is the fourth law of thermodynamics that I added. Basically is the system has to reset once it reaches minimal energy output. Okay, it reduces to ash and nuclear energy and electric energy. Okay, so that's now all you have again. Okay, all collapses over again after eons. Okay, this is when the universe basically works in reverse. It's losing entropy now, and it's a non-equilibrium system. That means it's starting to grow and gaining energy from its surroundings. This is how a cell works. A cell does the same thing. It uses the energy from the surroundings to grow. Okay, and this is exactly what this is doing from nuclear and electric energy, the male and female energies. Okay, this has been literally the first cell. This is literally programming how life is going to form and matter and everything is going to exist. Okay, now it tightens into a singularity. Like the phoenix rising from the ashes, it rebirths another universe. Okay, like a cell that's a low entropy system, the singularity is the same way. It can self-replicate. Basically, it's growing from its surroundings. It can extract energy from its surroundings. Okay, that's like a cell does. Okay, exchange matter from its surroundings. That's what it's doing whenever it's going to literally go into its Big Bang. It's going to gain its energy and it's going to shed it when it explodes. It absorbs energy from its environment. Okay, it's a non-equilibrium system. Non-equilibrium systems, perpetuation for life. That's how life exists. Okay, it's a living energy. Okay, living energy. Everything comes from nuclear, electric, or chemical energy. These are potential energy. Okay, once this thing forms into a plasma singularity, it is literally it's living. I mean, plasma is alive. Everything that's plasma is alive. It's a living energy. Okay, so this means it's literally the non-equilibrium system that has low entropy. Okay, because it's hotter than the rest of space. All right, so now the entropy, second law of thermodynamics. All right, this is before the Big Bang. Okay, you have these self-born quarks, the micronova, E equals mc squared. Nuclear energy is emitted. Carbon traces, also the ashes, because everything reduced to ash. Okay, so you have traces of carbon in here. Okay, now space is cold but cannot go to ground state because there's no ground for stationary existence. So you have nuclear popping and electrostatic crackling because there's no electromagnetism yet because you do not have uniformity with these electrons. You only have random electrons. Okay, they haven't came together yet. You have no singularity yet, right, at this point. Okay, so this is before the singularity. Now you're only going to have static instead of electromagnetism. There's no electron uniformity. So you have the minimal energy output. It's a thermal equilibrium, uniform temperature. It's nearly absolute zero, okay? It's void of matter, but not energy, okay? So this would be like before the singularity. And after a singularity has burned out, there would be carbon traces of ash where it was the remnants of it, okay? And it may even be in here from micro ash, basically from these micronova. I mean, a quark is, these are little micronova. They are self-born. Okay, so space is an open circuit system. The universe is a closed circuit system. So a universe is a system inside an open system. It's a closed system inside an open system. That means it cannot, after it has reduced, it will literally reset on its own. Nuclear and electric energy, potential energy, can only gain in an open space system. Okay, analogous to a snowball rolling downhill and gaining energy and momentum. Okay, until it ends up reducing after it reaches its complete rest. All right, but in space there's no ground, it can't rest, so it has no choice but to go back up. Okay, slowly losing entropy. Okay, as it starts to gain and turn back into the singularity, which is low entropy. It's a non-equilibrium state. That means it is not in thermal equilibrium with its surroundings. It's completely hot. It's a lot colder in space. Okay, singularity is hotter than surrounding space. Surrounding space, okay, is here, all around it. Okay, space around singularity is significantly cooler than the singularity. Plasma is hot and loud, emitting light and frequencies. Okay, there are sound frequencies because literally plasma stars are loud. Okay, there is a sound or a song that the stars sing, but it's very loud. We just can't hear it because there's no air in space to propagate, but there is still a sound there. Okay, that's the dark matter. That's literally giving density to the universe. Okay, and momentum to galaxies and holding things together. Okay, as long as space around point zero is significantly cooler, then there is very low entropy. As point zero cools more and more of to temperature of space, it gains entropy. Okay, that's basically whenever it's almost at its zero state. That's when it's reduced to nothing but energy and traces of carbon. Okay, minimal energy output will be reached and it will reset. Okay. So now you have the surrounding space here. It's cool, and then now the universe, okay, is born. The universe is hotter than void space. Okay, the space around the universe, the infinite void space around the universe, is a lot cooler than the universe itself. Okay, it's a non-thermal system. It's a non-equilibrium. Again, for life. Okay, for life to propagate, a non-equilibrium system. Okay, now the Big Bang Theory and the Plasma Universe Theory, and I haven't decided on the name. I call it the Living Universe Theory or Macrocellular Theory. Cosmic cellular theory, but it's basically chronotheism. All right, you have a quantum zygote. Zygote becomes embryonic. Cosmic plasma, the male and female energy, comes together to form the first cell, cosmic cell, which is the singularity. Okay, you have the alpha and the omega. Okay, it starts from the microcosm and grows to a macrocosmic scale. Okay, it starts very, very tiny. From the world we can't even see, but we know it's there. It's the quantum realm. It starts that small and it ends up growing. And that's the thing with gravitons and gravity. And I'll explain that here in just a second. Okay, it's growing, gaining energy from adjacent space as a cell does, cytokinesis. Okay, and it expands into a living universe. Now here's the thing with gravity and gravitons. Okay, now here's infinite space around this, and there's the universe. Now the universe is heavy. Okay, space is feeling the weight of our universe. Okay, things that might seem very far apart inside our universe is actually very close together on a macrocosmic scale. Okay, space feels the weight of our universe. Gravitons exist on every fundamental cosm. That means they exist in the tiny cosm, they exist on our very fundamental plane, and then they exist in the macrocosm. Okay, and that's the thing with gravitons and gravity. It's all connected. Gravity exists on all these cosms. Okay, the dark matter gives density to the universe. Okay, that's the sound and frequencies that gives matter the momentum in these galaxies. It gives galaxies momentum and holds things together. Okay, it helps hold them together, and that's the sound of the stars. Okay. Alright, so space is an open system with no ground. Okay, the universe is a closed system, absolute zero ground state. Okay, near zero. Alright, it has no place else to go but up. Okay, it's maximum reversion. That means it reverts completely back to carbon. And maximum entropy, that means there's no energy hardly at all. It's almost zero. Okay, nearly zero state, no ground, infinite, open. Okay, nearly thermal equilibrium. Okay, now this is the Higgs field. Okay, the scalar field or the microcosm. Okay, that's when carbon, nuclear, and electric energy recoalesce into a microcell or the singularity, a self-born universe from the microcosm inside a macrocosm. Okay, electrons won't interact with the strong force, protons, because the neutron remains in plasma state. That means this is literally living energy and it's recollapsing. Okay, so when it is in this state, you have your gluons, your vector boson, okay? Strong interaction. That basically holds your nucleons together, your protons and your neutrons, your up quarks and down quarks, okay? And as it is collapsing like this, you have your Z bosons and your W bosons. These are your gauge bosons that literally will help and transfer energy and spin to these particles as it collapses in, okay? It's in zero spin because it's Lorentz transformation. Basically, this is a nuclear transmutation that is happening in this scalar field when this singularity is forming. Okay, so that's why we get these relative particles or elementary particles literally, because when they say, oh, we're trying to figure out what's happening before the Big Bang, well, why aren't they trying to figure it out? Okay, basically, I feel like I'm the only one trying to do anything about it. I'm not trying to be cocky, I'm just saying. So, literally, you have these particles that are being created because you have all kinds of random frequencies here, and light and sound and popping and nuclear energy and all kinds of fluctuations going on. So you're going to get all these particles. You're going to get the gluons and the bosons, basically, and eventually you're going to get the Higgs boson. Okay, this is the scalar boson. Okay, after it goes Big Bang, you have your population 3, your population 2, and population 1 stars. All right, that's when you have basically pure hydrogen that has formed. Okay, because the simplest atom is going to form, and that is hydrogen atom. All right, and once it fuses, this generations of stars are going to end up having hydrogen, helium. Then you're going to have hydrogen, helium, and lithium, and then they're going to end up forming heavier elements. Okay, so this is literally a theory from all kinds of facts that we have here now that I've been trying to put together to try to give us a new perception or perspective on things. So literally, before you have the singularity, you have void space, or the chaos. Okay, the vast chasm or the abyss, emptiness, the mind. This is basically conceiving a universe. Okay, this is a space conceiving a universe. Okay, this is like the uncreated creator, the will and potential, or potential and inevitability. The Holy Ghost, quarks, which are self-born, nuclear energy, alpha, or the first, proto, the first, or the heavenly father, because it's the male energy, okay, which literally will emit beta decay, and that will be the omega energy. So literally